guys, this is Nazmus Simab and you are watching GetWays Solution. In this video, I am going to solve array question from LeetCode, and question goes like this. Given two sorted integer array nums1 and nums2, merge nums1 into nums2 as one sorted array. The number of elements initialized in nums1 and nums2 are m and n respectively. You may assume that nums1 has size equal to m plus n such that it has enough space to hold additional element from nums2, which means that here we have two array nums1 and nums2. In nums1 we have element till m minus 1. At 0th index we have some element, at first index we have some element, at m minus 1 we have some element, and from m to m plus n, here n is 3, from m to till m plus n minus 1 we have zeros, which means that it can be replaced by other element from nums2 or from shifting element from nums1 only. So we have two array here, 1 2 3 0 0 0 and 2 5 6. We have to combine these two array together, means we have to merge this array into this, so that this all empty space which is represented by 0 here will go away, and in place of that here some element will come, and after that we have to sort them, and sorted array will be something like this. So there are two way of doing this. The first way is a very simple way, but in that way we have to, our time complexity will increase. So first we will try a simple and bad approach. So here is the approach. The approach is very simple. If you see from this position we have empty space got started from here to here, and we can call this position as m, right? Because this index is m, right? Because m is 3. If you go like 0 1 2 and this is 3, and this position we can call it as m plus n minus 1, right? M plus n is 6, and this if you do here it will be 5. So 0 1 it's 3 4 and 5. So if you will iterate here from m to m plus n minus 1, and let's take a variable j and initialize it with 0, and what we will do here, what nums 1 of I, let's call it as I equal to m, nums 1 of I. What we will do, in place of nums 1 of I, in place of 0, we will move this element, this nums 2 of j, and after, if j is here, for now j is 0, so it is pointing here, and after doing this we will increment j so that it will point here, and we will increment j plus plus, so that our new array will become something like this: 1 2 3 2 5 and 6. After doing this whole step, what we will do, and our new nums1 array is this, right? After doing this, what we will do, we will simply call array dot sort nums1, and it become this, and after calling sort it will become this. So we reached our solution. But if you what is the problem here? If you see, first of all, for iterating from here to here we will end up with m iteration, and for sorting we will end up with, if you know, the best algorithm of sorting have time complexity of big O of n log n. So overall our time complexity will become m plus n log n, and it will be O of n log n. So which is a bad approach. If you see, we have in question we have given that this is sorted and this is sorted, and we didn't make any use of it, and so we end up with this time complexity, which is very bad. So, and we want a time complexity should not be n log n. We want time complexity should be n, big O of n. How we will achieve it, we will see. Okay, first we will try this approach in coding, and next we will see how we will improve our solution, optimize our solution. First of all, write unoptimized solution. We'll try to write unoptimized solution, and it will be something like this: int j equal to 0, and for int I equal to m, I less than m plus n, and I plus plus. And if we have this condition, what we will do, nums of 1 of I, in place of this we will move nums of 2 of j, and after doing this we will increment j, and after doing this whole thing, what we will do, we will arrays dot sort which one, nums of 1, because we are storing all element in nums of 1, and that's the solution, and it's the bad solution. It is the bad solution, and let's try to submit it. Hopefully it will get accepted. Yeah, it got accepted. Now we will see a good solution, optimized solution with time complexity of big O of n. So now we will go with a better approach, and that approach is two-pointer approach. What we will do here, first, let's try to create nums1 here. First element is 1, second is 2, third is 3, fourth, fifth, and sixth. We'll give index to it 0, 1, 2, 3, 4, and 5. And nums2, 0, 1, 2. And the elements are 2, 5, and 6. And now what we will do here is, we'll give two pointer. Pointer 1, let's call it as P1 and initialize it with 0. And P2, initialize it with 0. And we will do what? We will do create a duplicate array of length m plus n. And now proceed toward the solution, and solution will be, we will first iterate over the duplicate array for I equal to 0 till m plus n minus 1. And in each iteration, what we will check, if this array nums1 array of P1, if the element here is less than this, right, is less than nums2 of P2, what we will do? This is our dupe array. 1, 2, 3, 4, 5, and 6. 2, 2. Okay, right. In this, what we will do, if nums1, if this element is less than this, in dupe array, we will place this element, with the element which is less. Okay. So here, what we will do, dupe of I, we will place it with nums of P1, nums1 of P1. And after doing this, what we will do, increment, update this pointer, and this pointer will now become, update this pointer, and this will become, P1 will become 1, right? Increment it by 1, P1 plus plus. And if we are doing this, and since we are doing this, when we will reach the last element, and at that time when we will increment it, it will give array index out of bound exception. So we will see that in later in code, we will handle it. And after that, else, which means that nums2 P2 is less than nums1, means reverse of this condition. Okay, in that condition, what we will do, dupe I, duplicate of I, in duplicate array, what we will do, instead of P1, we will do nums2 of P2. And in this case, what we will do, increment P2. And this is the solution. And if you see in this complete solution, we are using one for loop. And what will happen? The sorted array will be placed in 2, 2, 3, 5, and 6. And this is dupe. But we have to return nums1. So we have to copy a dupe element into nums1. So we have to write one more for loop for copying. You can use clone also if you want, but that is something which is completely new from I equal to 0 to m plus n minus 1. We will not use clone. We will use simple approach to copy. What we will do here, in nums1 of I, we will copy dupe of I. Because we are returning nums1, so that's why we are copying it. So if you see here overall time complexity, here what we are going to do, we are iterating from 0 to m plus n minus 1. Let's consider it as n. And what we are, this is not nested loop, these are two individual loops. So it will get added next time complexity again n. So it's 2n. If you see the time complexity, it's 2n, which we can call it as big O of n. So now we have time complexity big O of n, which is a better solution than previous solution. In previous solution, we have time complexity big O of n log n, which is huge as compared to this one. So now we will try to code. When we will code, we will see various updates in the code. We will try to resolve some array index out of bound exception. And since these elements are 0, right? These elements are 0. And if we will compare these elements, suppose 0, and we will compare it with 2, obviously 0 is less, so 0 will get placed, but we want to avoid these elements. So for avoiding this, we can add a condition in our if, like if m, which is if P1 is less than m, then only run this condition, right? Similarly, here also we can write this, if P1, if P2 less than n, then only run this condition. We will check based on error we get, based on exception we get, we will update this code. Okay, now let's proceed toward our code. So this is the previous solution here. but we will try to update the code now. First, I'm arranging this. Okay. Hopefully you are able to see all the things correctly. Now write the code. First two pointer, let's call it as p1 equal to 0 and p2 equal to 0. And if no, for loop we have to introduce for loop for int I equal to 0, I less than m plus n, because our array length is m plus n, nums1 array, right? I plus plus, and then what we will do, we will check the condition if nums1 of I is less than, not I, it's p1, right? If nums1 of p1 less than nums2 of p2, then what we will do, and we have to give a duplicate here. We have to initialize and declare duplicate array also, and let's consider that array as int dup array, and size of new duplicate array will be m plus n, right? So what we will do here in duplicate array of I, store nums1 of p1. Else, and after doing this, what we have to do, p1 increment p1, else dup of I. If this condition is false, which means reverse is true, so dup of I, what we will do, nums2 of p2, and in this store, after storing, what we will do, increment p2. So that's the code. But here, if you see, if I will run this code, we have some problem. Let's go below. Yeah, we have many problems now, in fact, because we have done this whole thing in duplicate array, not in nums1. So there is no change in nums1. So what we will do, what we have to do, we have to copy a dup array into nums array. For copying, we will run another for loop, and this is not nested for loop, so time complexity will not increase anyway. Int I equal to 0, I less than m plus n, and I plus plus. And in this case, what we will do, we'll copy duplicate array in nums1 array. Means a duplicate array element will replace nums1 array, and now we can, of course, we will not get solution here. We have to make some update in update. So if you see that 1, 2, 2, 3, and 5 and 6 is not appearing here. Why it is not appearing here? Because comparison is done between 5 and 6, between 5 and this 0, and obviously 0 is less than, so this if condition will run. So we have to give a condition here to avoid this situation, and the condition should be like this, p1 should be less than m. Now hopefully we are now closer to the solution, but obviously now also we have to make some update. So if you see that now we are getting the same answer as expected, 1, 2, 2, 3, 5, 6, 1, 2, 2, 3, 5, 6. But now if I will try to submit this code, we will get one exception. And the exception is like this, array index out of bound exception at line 10. Now what is happening here, if you give output as 1 and another empty output, which means that this time length of array is 0, and what we are checking, since length of array is 0, but we are checking what? We are checking this condition, length, there is nothing in array, there is no array, and we are checking that is the index available. So of course we will get array index out of bound exception. So before doing this, we will create one condition. If n equal to 0, then do nothing, simply return, which means that if n is 0, which means that the second array didn't contain anything. So obviously we will return array 1, and that will be the answer. Of course, again we will run. We will again get array index out of bound exception, but this time at different. This time the exception is different. Here, what is going on? Here we have one element in first nums1 array, and in second array we have one element. If you see this complete thing, understand this in whiteboard. Let's try it in whiteboard so that we will understand it deeply. So here we have example 2 and 0, and nums1, this is nums1 and this is nums2, and it has only one element. What will happen? First we will compare this and this. Obviously, nums2 is less, so else will run. And after running else, what will happen? P2 get increased. P2 is now 1. And what we are doing here is we are comparing that index. We are calling that, checking that if nums at P2 is greater than nums at P1. So there is nothing in P2. So how it will run? Of course, it will give array index out of bound exception. So what we have to give condition here? We have to give one more condition. And the condition is P2 less than n. If P2 less than n, then run this condition. But again, we will get one problem. We will get one wrong output. This time we will not get exception, hopefully. Yeah, we are getting exception, but what we have to do here, we don't have to compare. If P2 is less than n, what we will do? We will write one more line, and you try to understand this line. I will simply write here, and you have to understand this. Well, this is the critical line. If P2 greater than equal to n, then what we will do? We will simply copy paste this. Simply copy all the element of first nums1 array into dup array. Because why we are using or here? We want to avoid this condition. If it become true, simply enter into this and copy all the element of nums1 into dup. Because there is no element to compare only. So hopefully it will run now. Yeah, our solution got accepted. Now if we see here our time complexity, you are here, your runtime beats 100% of Java solution submission. Means we are ahead of everyone if we submit this solution. So that's the video. Hopefully you liked it, and consider subscribing and sharing. Bye bye. Thank you.